Okay, good morning, everyone. Today we continue our discussion and we learn a new tool over Hadoop core system, which is a Spark. So as we had a small introduction before, you can work with the Hadoop core. You can work with the HDFS files and yarn and run your MapReduce functions. But as you might remember in the previous assignment, it's much more difficult. And let's say you want to do text mining, you want to do like some machine learning jobs, it's much harder if you work directly. Having said that, people make some tools over the Hadoop core to make your life much easier, which in the previous class, we learned how to work with Pig. So as you see, since you already have SQL Server or MySQL knowledge, working with Pig is pretty much easy for you. Basically, instead of taking care of a MapReduce function, you just take care of SQL codes, and that's it. So makes your life easier. And in some cases, more specifically for Spark, they just said that they made a more efficient approach. So even they claim if you work with the Spark, you might even 100 times faster than working with core directly, but it's what they claim. Who knows? So also your TAs started to install Hadoop and Spark in the lab. Let's see if they can. This semester is a bit challenging because it's very hard for them to talk with the IT people because of COVID. I mean, hopefully they can, but at least they get admission, authorization to do it. So just wait one more week to see if we can get it in the lab. Otherwise, I recommend to install Hadoop and Spark or Pig, whatever, directly on your computer. It makes your life is challenging to install, but it might save a lot of time for you later, and you get some good technical knowledge out of installing Hadoop and Spark over your system. Okay, that's for that. Also for Spark, I supposed to make some asynchronous session for you, especially if you remember one day we didn't have a class. So installing Spark takes a bit of time, which probably, we don't have enough time to install it this session. So maybe, tomorrow or anytime this week, I make a video for installing Spark in your system. But you can easily find good tutorials online. I recommend to install the version 3 of it because there is some certain updates. Like, for example, one topic is RDDs that still exists in Spark 3, but they don't maintain it. So if you see some issues in the RDD system, you might figure it out by yourself. There is not that much of support, but it's on this in the business. So if you get a job right now, you might face those concepts. So it's the reason today I review them, but I assume they will fade out soon. Any question from previous classes, your assignments? Okay. By the way, today might be a little boring. We go over some general concepts, but for working with actual thing, which is working with the Spark, you need to get some general ideas. What does it mean? So hopefully from next class that we do hands-on experiences, those concepts makes a lot of more sense for you. But for today, we just go over them and skim through some materials. And but I also recommend to go over slides, but it's not, I don't evaluate you by your memorizing these concepts. So let me go to start. So you might remember we had some issues in the Hadoop when your data gets larger and you need extra computation needs. You have two approaches. One approach is just make a larger and more faster and powerful system, but there is a certain limitations on it. Either budget-wise because you need to design by yourself, which makes your cost much more expensive. Or you can use high-end market computing nodes, which is still not cheap, but it's much cheaper because they already designed for everyone. So you can use several of them in parallel and increase your speed and power of your system. So on top of that, we already talked about the like Amazon example. Let's say they are very rich and they can make a very large super center and make the best and fastest supercomputer in the world, but it's not a good option. Let's say they make a supercomputer in Seattle and suddenly they lose power or they had a like virus attack. What happens? They lose their business. So although they have almost unlimited budget, but it doesn't make sense as it's not a good option to just make a really large super center to take care of your business. There is some communication issues. Is there Amazon in China and India too? In India? So let's say you want to buy something in India from Amazon. So it doesn't make sense that you connect to a server to the US, do some transaction, and it's like there's some communication lag and also privacy and security issue. Yeah, they can easily make a server or not one, several servers in India. So you just work with those servers. Okay, let's read this famous quote from Grace Hopper. She was one of the earliest computer scientists, data scientists, or machine learning scientists, whatever you name it. In pioneer days, they used oxes for heavy pulling. And when one ox couldn't budge a log, we didn't try to grow a larger ox. We shouldn't be trying for bigger computers, but more system of computers. Let me just show a picture of oxes. Let's do for farming. They need to just pull a certain load. So they have two options. Maybe they know some biologists that work on DNA that they can make large oxes, but there's certain limitation. They cannot make a dinosaur ox. So the better option. So if you have a ton of cargo, maybe you can use several oxes in parallel. Similar for computing power, as she said, I think she's generally talking about parallelism and working the systems in parallel instead of just making a larger and larger system. Okay, these two figures is just what talks about what I'm saying. Traditionally, you had a super center that takes care of all of communication, but these days you have several centers work in parallel. And as we already said, in all of the nodes, you have the data, so they can just divide or map the data in different centers or clusters or nodes and run the process in parallel. Similar to Amazon India, even if all of the Indian server just got failure or failed, they can just access to the nearest supercenter or computing nodes, maybe in the neighboring country, or even they can connect to US. So it's much more logical and better option to just do parallel systems. So, but what is Apache Spark? It's a fast general engine for large-scale data processing on a cluster. I think there's some font issue. Large scale, it's like large 5, sorry. I mean, it's not a typo. Let me just, it's very hard to, or fastest. I'm not sure. There's some certain font issue. So this project is started in 2009 and it has several contributors. So For example, Cloudera, which is you're working with HTTP 265, which is under Cloudera. It used to be Horton, which was purchased by Cloudera, so it's now Cloudera offering that. Databricks, Berkeley, UC Berkeley, Intel, Groupon, all of them contribute in this project. Especially Google is a big contributor too. So the good thing about, I mean, there's a bad and good thing about the Hadoop ecosystem, which Spark is a part of it. It's quite challenging at this time because it's still evolving. But the good thing, if you get good knowledge, I mean, if you can claim that you're a Hadoop or Spark programmer, it's bringing a lot of advantages because there's not that much of people can do programming in this platform. Like 5 years ago, if somebody knew machine learning or could do programming Python, there's a good market for that. Still, there's a good market for it for people who can do analytics, but many people knows that. And as you see, there's so many programs in parallel. So they have data science, data analytics, business analytics, information systems. So you need to work on the edge. Even maybe you can get a job that there is no need for Spark, but if they know that you know Spark and Hadoop, it means you are a very sophisticated person. You have a very good, deep knowledge of machine learning. So it's a still, I recommend to spend further time. So on top of it, and let me. It's a complicated topic, but I need you focus on your project. Most of your project is under Spark, so you need to learn how to use machine learning packages and algorithms and those kind of things. Do analytical programming over Spark. You can do over Hadoop core, but it's much more sophisticated. It's very difficult just do all of those MapReduce by yourself. Similar to your data analytics programming and even visualization course, it's a good time to start to find a good data set and project. So just in next month, try to learn further from Spark and try to find a good data set for your project. Even if you target a paper, it would be great too. There's not, I think last year I couldn't find any paper somebody used Spark for research. So it just means there's not that much of people are working with that. Maybe this year some paper published, but I haven't seen any so far. So this is the general framework of Spark. As you see, it's on top of Yarn and HDFS. Just makes our life easier, and you can do very sophisticated, almost anything that you do in Python, you can do in Spark. But it just, working with the Spark, you don't need to take care of infrastructure and focusing on like which cluster works with which cluster. Basically, Yarn manages the infrastructure with you, for you. HDFS contains the file for you, but Spark, you just run the code, and Spark core, also Spark has a core that like negotiate with Yarn and HDFS and take care of the remaining. This is a high-level programming framework. High-level just means that you don't need to do many basic things. Just one of them is Hadoop MapReduce, so it takes care of all of them. Similar to Pig. In Pig, you know, you didn't need to do any MapReduce. You just use your knowledge in SQL programming or MySQL. Basically, you did MySQL for just doing MapReduce, and you got some queries, very simple queries. So this is a distributed, data is distributed in several storage nodes or data nodes. And data is in the memory. So what does it mean? For a faster process, instead of working data in the hard drives, I'm just making it simplify it. So in the nodes, you have hard drives, you work with the RAM. Memory here means RAM, computer RAM. So what's the differences of working in the computer RAM and hard drive? What's the biggest differences? So why your computer has extra memory that they call it RAM memory? You have a hard drive memory, so why your computer has a RAM memory? Shashank should know that you have a.
RAM is like for the real-time processing and hard drive is for the storage of that.
Both of them, yeah.
Both of them do the storage part, but one RAM keeps on running the process and tells it if it's, the system is hanging, and hard drive is keep on the system based on the memory.
Basically, both of you are saying some correct things in different aspects. When you work in the RAM memory, your process is much more faster. Hard drive is kind of slower, and you can Google and look at the differences of in terms of gigabyte, compare the price of gigabyte, 1 gigabyte or like 10 gigabyte, whatever, RAM and hard drive, you see the differences. So one of the reasons why Spark is fast, working with Spark is much faster than working with Hadoop core. Hadoop core is over hard drives. On top of that, they claim that they made some efficient algorithms. So 2 reasons could be for the faster process in Spark. One of them, as your friends talking about a stream. So when you have a stream of data like tweets, comments, like YouTube videos, whatever. So these are coming a stream. So and sometimes you want to do process online. So whenever you get data, you do process and get some insight. So for those cases, you cannot use Hadoop because it takes a lot of time to save them, process. But if you save them on memory, RAM memory first, you can just process very fast and record it later. So if you want to do stream analytics, you should work with the Spark. It's almost impossible to do in Hadoop. And the good thing is you can raise your nodes, and it's almost linearly you increase your capacity. The capacity could be a processing capacity or like a storage capacity, but this is like very scalable tool similar to Hadoop. Basically, in Hadoop, you also increase your storage capacity linearly when you add further nodes. Another good thing is the fault tolerance. It has a good amount of fault tolerance. What does it mean? Similar to Hadoop, if you have some of your nodes, you have failure on some nodes for any reason, the Spark codes just manage other nodes and do the process with the remaining nodes. But your processing capacity is lower and you do process slower. The major users of Spark are Yahoo, Conviva, Technicolor, Uyala, something like that, or Groupon, whatever, Nokia, other companies. The main, it just means, I mean, if you're looking industry jobs and there's they want to a business analyst or data scientist in those companies, as you see, they are working with Spark. They rather have somebody who knows how to work with the Spark and Hadoop. Your job may not contain it, but you have some extra advantages that you already know how to work with them. So these are common Spark uses. I mean, as you see, might be very similar to other platforms like extract, transfer, load, which is like similar to SQL. Text mining, index mining, so it's similar to Python. Graph creation and analysis, pattern recognition. Graph creation and analysis is a different knowledge, so you need to spend like several courses, but basically it's something like how Uber or some transportation companies work. I mean, is a very certain domain, but it still is available under Spark. Prediction model, sentiment analysis, risk assessment. So for your final project, you do even if you have knowledge of graph analytics, that should be awesome, but you can do that. I don't have that much of knowledge in graph, but I take it. You can do text mining, index building, prediction models, those kind of things under Spark. So benefit of Spark. now it can take care of stream of data, very, large amount of data, lower cost. Although we use RAM and it's more expensive, but instead of having a large supercenter or supercomputer, you have several commercial high-end computers. So still you reduce costs somehow. Very flexible and linear scalability. You add nodes and you get faster processes. Okay, so this is like general Spark codes. No worries, we go details later, but I'm not sure if you can see it, but it's very similar to Python. There's some certain differences, but, and we have, we run an sample Spark code today. So, yeah, Hadoop developed over Java. Spark developed by Java and Scala or whatever. Scala, I think is a better pronunciation. But you can either be a Hadoop or Spark engineer or a data analyst or business analyst. So you need to work with this environment. You don't need to, they may hire someone to fix the issues or warnings or problems, but you don't want to, it's a different, a different job domain. If you can spend time on it and learn you can, if you want to understand the structure and issues that Hadoop and Spark ecosystem might get, you need to have good knowledge in Java or Scala and just go inside the structure. It's an open source. So yeah, that's a certain job domain actually. So any questions so far, even from the people over Zoom? Yeah. Spark is built over Hadoop. So in your system, for working with Spark, you don't need to install Hadoop, especially if you're working Windows. But even in that case, you use WinUtils, which mimic the Hadoop ecosystem. So it should be built over Hadoop. When you install in your system, it might be already embedded. When you download it, it might be already embedded in your download. But it should be there somehow. So I show you in this slide. Let me just go first. So look at Spark and Hadoop. So, in previous class we had Peak. Maybe instead of this tree, instead of Impala, let me just put Peak. What happened? I'm not sure, there's some issues with the font, but let me just put Peak anyway. So Peak is over Hadoop core, which you can, instead of doing MapReduce by yourself, you just do over Peak. So still you need to have MapReduce, you need to have Yarn, and you need to have HDFS. Same for here, Spark. The Spark core is over Yarn and HDFS. Basically, it just communicate with those Hadoop core ecosystem things, but you cannot just be a standalone for nothing. Or you can, there is some development environment that they mimic that. That's the case, but the big, yeah, in those environment, you can assume that it's kind of independent, but the reason that you use a Spark is for parallel processing and stream processing. So it's not that much of a point to do that, even if they make some development environment for you, but it's not the point. It's not the point of working with the Spark. I think I saw, yeah. So this is like the most famous tools or packages that developed for Spark. These projects are the most famous one. As you see, over a Spark core, we have Spark streaming for analyzing stream of data. We have Shark, which is for SQL programming. So you can do it, use Pig or work with the Shark SQL here. MLlib is machine learning library, and probably your project is would be done mostly using MLlib. Graphics, and even you might have, I think it shouldn't be Shark, it should be Spark SQL. Yeah, I got it from Cloudera. I think they had so many typos. Spark R, so if you already have R knowledge, especially if you want to go biology and biostatistics, probably you need to work a lot with R. This is their general language in the like healthcare domain. They do a lot of R scripting. So just what I talked with your friend, Spark uses HDFS, Spark runs on Yarn, and it can work and collaborate with the other Hadoop ecosystems such as Scoop, Flume, and HBase. If we have time, I teach a little bit of Scoop, but our focus is on Spark. So if you have, if I'm confident that we have enough time, maybe spend one session for using Scoop. So this is the general pattern that you see. Okay, this is the general comparison of Spark and Hadoop MapReduce. As I said, you don't have to have Spark. You can do everything over Hadoop, but the biggest difference is Hadoop is well developed, is a little older, but the best advantage of Spark is much faster. You're working over RAM. And there is different applications too. For example, if you want to do a stream analytics, you cannot work with the Hadoop. Doesn't make sense. It's much slower. For Hadoop, maybe if you have a very large amount of data set and you just pile it up somewhere, Hadoop is a good option. But for streaming, those kind of, you need to fast analytics, probably you need to work with the Spark. Okay, let's talk about some basics of Spark. So the data in Spark is recorded in RDDs. It stands for Resilient Distributed Dataset. So dataset that makes sense is a dataset. Resilient means it's fault tolerant. So you have several copies of your data in case you have issues. You take the required data from somewhere else, distributed. Again, makes sense. We are doing parallel processing, so it's processes distributed over several nodes. So Spark actually is written in Scala. So similar to Hadoop, Hadoop is written in which program? Java. So for in case you see some issues and errors and like some structural problems, you need to know Scala. Just go inside the open source program codes and find the issue, but Python is more than enough. So for machine learning analytics, they already made all of the packages available in Python. Usually if there's something new, it first comes in Scala, but quickly they just make something similar in Spark R and Spark, PySpark. So no worries, PySpark is more than enough. And this is the shell. So let me, I think installing Spark over on your system shouldn't be difficult. If you install it with this command, you see this shell. Like if you do PySpark, you do Python shell. If you do Spark shell, you go to a Scala shell. And after that, you can just do simple Python programming. So you can just type your script there. But usually for large scale programming, we don't use this shell. Usually we make our code with some development environments, then submit it to Spark, which I talk it later. But I don't say you cannot do the programming here, but it's better to just make your code somewhere, and when it's ready, just submit for calculations. Just again, please spend time to go over this concept. I mean, slides that I provided. But RDDs, I mean, just as a very short example, again, RDDs might fade out, but if you get a job in the for working with Hadoop, still is in the industry, but people expect that it would fade out soon. So as an example, when you load the text into Spark ecosystem or Spark core, each line of the text is a RDD, and it's the way that it takes your data. So it's basically your data units, just lines of the text. This function, sc.textfile file address. This is the function. Pardon me?
This is a functional library.
This is actually, I mean, I talk about the detail. I do a simple example later, but yeah. Mm-hmm. So you most likely, I mean, actually, you have two types of basically operation of RDDs. One, you take your RDDs and do some calculation and get a value, or just copy a new RDD, which is not recommended. The second one is not that much recommended because you are working with a large data set. It's not that much a point to just make an exact copy somewhere else. I'm talking about I would talk about pipeline and lazy execution. Sometimes you just make a pipeline. You don't necessarily make a new copy of your data. So look at the question. Which type of operation is count? Count function. Is it the, yeah, first one. You count number of RDDs that you have in your file. These are some general function, transformation. So look at the left side that we are doing over Python. So, and the concept is map. Basically, map just means you assign a lambda function. If you remember in Python, it's just one way of defining function through lambda. It just means a short way of defining a function. So, like map means assigning a lambda function of line to this RDD, and what it does, it just make uppercase. In this second one, we filter using a lambda function, and we just take the ones that start with I. So you see the result. So this is the step, like load the data, do the uppercase, take the one that is started with I. Look at here, we define 3 lines of code, or more than that, actually 3 lines, yeah. So, but you don't see any result. This is lazy operation. It just means you define like pipelines or like a series of processes and code, but you don't run it until you just let it run. If you don't let it run, it doesn't do anything. So you press enter, go to next line, press enter. It just means you enter an RDD object, you do something and you define some function and process on it. But at the end, when you do the execute the operation, it just execute all the pipelines. So you just call it lazy operation or execution. It just means you define a pipeline and then let it run. Not a big thing, it's just a technical term. 9. Again, we work with the function definition because we are working with the pipelines and lazy operations, execution. So you need to know that in this kind of operation, you define several process and functions that you apply to your data object. So that's conclusions. Okay, these are the key points. First of all, you can use Python for very effectively. It works with Spark code, and with that Spark code, you can do several machine learning jobs. You learn what does RDD means. You either transform it, or even you can create a copy, or you do some actions or functions on that data. And the technical term is lazy execution. Just let me read that. Transformation are not executed until required by an action. Basically, you do some transformation, you do a series of code and define a pipeline, and it doesn't do anything until you let it done. So it's just not a big thing, it's just a technical term. So, and we do a lot of functional programming and object-oriented kind of programming in the next classes. Let me see. This one, yeah, you can skim through the next PowerPoint, but this is just talking about some general Python coding or some PySpark coding, but we have some lab that we go over them, but no worries. I mean, too much for today. Okay, for today, please go over your Moodle and download ratingspark.py. Also, you should already download the movie lens dataset. So download both of them. I make a Spark codes folder on my C drive. If you want to run the code that I posted on your Moodle, you should have the same naming. Otherwise, you should change some names. If you use different folder names, you should change your code. So make a Spark codes folder on C drive, and under that, make a data folder. And under data folder, put your u.data. So under data folder, you have u.data. Under Spark codes, you have ratings spark.py. I give you 5 minutes to do that. So for u.data, it's a movie lens data set you need to download from the website. I think because of copyright issue, I cannot share it, but you can easily go to, and you already probably already downloaded it somewhere. I mean, if you keep in different location, you should change the code. But I just recommend to just use my same naming, so you don't have to play with the code. And this is a Python code. If you make even one space by mistake or whatever, it doesn't run your code. So make a Spark codes folder, and under Spark codes folder, make a data folder. And on under data folder, put your movie lens data. So if you open the code, I mean, I know you're busy, but you see, I said my file is under Spark codes, under data, and under data I have u.dat. If you use different names, you should change this address. But if you use the same name, we can just work with this code. So this is the file address that Did you install Spark in your system? Yeah. No, it's not this code to Spark. Oh, you don't. I just got I thought you one scale. How you get around? How you get around? It's probably. Another one. I just downloaded it and. Open your camera. This is open. You might know. Okay, let's go over the code. I mean, no worries. This is your first experiences. Next class we'll do further. So it's very similar to Python. From PySpark package or library, import a Spark conf and a Spark context. Basically, a Spark context, as Shashank asked, is a fundamental object that you just do, like, makes an empty object and you do like further, like you add a file, you do some calculations. So you just you work with that object, and from the earliest part of your language, your code up to end. Also, we import collection. There is some function for sorting, so it's the reason we are using this package. So conf is just talking about, basically Spark conf is just talking about generally talking about your infrastructure. So from a Spark conf, we are just saying that we are running on the local system. So later when you work with the, let's say Amazon AWS Spark environment, so you are not working in local, you should be, for example, you have 8 computers, 10 computers, so you should talk about this. But right now we're just working with the local system, and we are making a web app name. Actually, in the Spark, your data usually is very large, and when you make you make an app, which basically during the run of your code, you can see what is going on, but this code is super fast, you don't see anything, it just runs super fast. But it's a good experiment to define a web app that when you get to a larger data, you can see what is going on while it's running on your code. So, okay, now we define SC, which is we just make a fundamental object of context using the configurations that we define here. Then we import our data and assign it as a part of SC object. We load it. So we load the RDDs, and as you see, look at this line. Now we have object of data lines. We're just saying in data lines, map, which means assign a lambda function, which in that lambda function, you split your input and take the location number 2. Here we want I'm so tired, I forgot to say what was the problem. The problem that here, we want to make a histogram of ratings. Sorry, when I teach 2 classes consecutively, I talk about the problem in the previous class. I forgot that I haven't told you what we want to do. Basically, in the movie data set, we want to look at the histogram of ratings. How many you have rating 1, 2, 3, 4, 5. So we had something similar before. Sorry. So what we do here, we assign a lambda function, and that lambda function, we take location number 2. But let's look at your u.data. So in u.data, first is user ID, movie ID, rating, and time, but the time is in the computer format. It's not in the human format that easily understandable. So my question is that why here we are working with column ratings here, but why I said location 2? Yeah, Python service 0. So 2 here means third column. Sure. Length. Could you ask me after class, because I'm confused with your question? Just please email me. So, okay. Anyway, now we use the method of count by value. We want to see how many. Basically, this one calculates the histogram. For example, how many 1, 2, 3, 4, 5. Just count how many unique values we have. Then we assign the value to results, and using a collection package or library, we order it with these 2 functions, sort and order dict. So now your value is ordered, And the last one, you just make a for loop and then print the results. So as you see, I said take key and value items from resulted sorted, dot items. And the format is S and I, S like a string, I integer, key and value. So a star is in the values, labels of a star is 1, 2, 3, 4, 5. It doesn't matter. You can even use $i, still you get the result, but it makes more sense to assume that the star label is a string, it's not integer. And then we print both values. But how you can run this code? I assume that you already install Spark, but no worries, I make a video for installation. And anyway, so let's say you open your terminal and you are in C drive. I go to CD, C, Spark codes. Now I'm in the Spark folder, the folder that has my Python code. Then I do this function, spark-submit, and the function name. You don't have to type all of it. You might have to type it, just type a little like rating, whatever. And when you press tab, it just auto-complete the remaining. So Spark submit, just submit your file into Spark environment. So as I said, you can directly code in PySpark, but it's much more efficient that you develop your code in one development environment, then submit it to Spark. So then press enter. This is, in some of the systems like mine, you get some warnings, but that should be fine. I saw for some of your friends, they never saw any warning, but for mine, based on my hardware, for some reason I get some warnings. But as you see, by the way, my data might be a little different. I assume your histogram should be a little different. I think I played with the sum of rows and columns, but you should get close numbers. You didn't get that? Did you get any?
On the line number 18, results in this results equal to rating in the score column dot found by.
Which one? Results? This one?
No, just about that. Yeah.
Which Spark instance? For me, let's just cut. So which version of Spark you install?
3.3.
Yeah, same for me. Might be, but in the previous class, people got the result. Okay, this is the way. From next class, we do more experiment with Spark, PySpark, and we start focusing on machine learning library and basically doing some data analytics programming that you've done within PySpark. Is there anyone else who can get a result? You got the result? No? Error? Might be folder address because you're using Mac, I guess. Sometimes the errors are not useful. So any Windows users, could you get the results? Okay, let me check your system. I think people over Zoom has questions. No, we don't have any assignment this week. Just try to install Spark over your system. So for next class, you will be more efficient, but there's no assignment.
Hi, Hamid.
Yes.
So for my for me, it show I don't have a Python, so I have to install Python first.
Yeah, I mean, so have you installed PySpark?
Not yet.
Yeah, if you haven't installed it, you cannot run it. So no worries, this is an example. So just Google it to try to find how to install a Spark. So, and after you install it, you should be able to run this code.
I installed Spark, but there is no Python function there.
Yeah, I mean, you should have Python on your system and Spark together. Otherwise, you cannot run this code. So it just means your installation is not complete. So if you successfully install Python and Spark, you should be able to run this code. Your results might be a little different because I played with the data set today. So might be like, instead of 6,111, maybe it would be 110, but it should be close.
Okay.
Just try to Google to see how to install Spark. And but anyway, this week I'm going to make a video just as asynchronous video, so you can see how to work with the Spark in how to install Spark in your system, Windows system.
Okay, thank you.
But if you use Mac, I'm not good at Mac, so Mac, Linux, but there is good resources online that you can learn how to install. Is there any other questions? So if there is no questions, that's for today. I go for your friends in the class and see if I can help them with their codes, because I assume they got some issues. But anyway, have a good rest of the week. See you next week.